Hi, everybody. I'm Drew Pearson. I'm a musician and an engineer. I'm having an awesome hair day. Look at that. Awesomeness. I thought I would share a PowerPoint presentation about compression with you guys. All right, so compression. What is it exactly? There's a common misconception that a compressor just makes the sound louder. And although it may sound like that to our ears, that's actually not what the compressor's doing. We need compressors because singers and instruments have a very large dynamic range. That is, they can be very soft or very loud. In the early days of recording, engineers dealt with this by turning the volume up to hear the quiet bits, and then turning the volume down during the loud bits so that the records wouldn't distort. Compressors were eventually invented to do this for engineers automatically. When the sound reaches a certain level of amplitude or loudness, the compressor turns the fader down and then returns the fader to where it was once the amplitude quiets down again. And that's it. That's all a compressor does. Makes the loud parts quieter and the quiet parts louder. So what are all the knobs and switches for? Well, these settings are for how loud the sound must be before the compressor starts to turn it down, how much the compressor will turn it down, how long it will take to start turning the volume down, and how long it will take to return the volume to its original position. Why don't we take a look at these settings one at a time? First one we're going to look at is the threshold. The threshold is basically the level of amplitude or loudness a sound must be in order to trigger the compressor. So once a sound source is loud enough to cross the threshold, the compressor is activated. But that doesn't mean it's going to start turning down the volume yet. Before it turns down the volume, it has to go through the attack. The attack basically tells the compressor how long it has to wait before it starts turning the volume down. In this case, once the threshold is crossed, the compressor must wait 10 milliseconds to begin to turn the signal down. I get asked all the time why we need this function. In the early days of recording, compressors weren't fast enough to catch really fast transients, like on drums or anything that has like a very strong hit at the beginning. The attack time was just too slow, so it would let the transient sneak by and then start compressing after the transient. Well, they realized that this actually gave the drums a punchy sound, and that's how we use the attack time. Basically, we can use the attack to change the envelope of a sound by letting the transient of a waveform sneak through the compressor at full volume. We can get more this kind of old schooly punchy sound. Knee is kind of a mystery to a lot of people as well. The knee is basically how abrupt the compressor will turn the volume down. So a hard knee is going to, as soon as the threshold is crossed, it's just going to turn the volume down all at once. But as you increase the knee or soften the knee, the compressor will begin to turn down the volume a little bit before the sound source reaches the threshold instead of all at once. So you can see here the compressor is going to start turning down the volume before the sound reaches the threshold, or as the sound nears the threshold. What this does is makes the compression sound smoother and more transparent, which is good if you don't want to hear the compression. There are lots of times we do want to hear the compression where we want to use compression as like an effect. But this would be a case when we soften the knee that we can make the compression sound a little more transparent. a setting of 0 with the logic compressor here is the hardest knee, while a setting of 1 is the softest knee. Next up, we're going to talk about ratio. Ratio is basically the amount of gain reduction, or the amount of volume reduction the compressor is going to apply. So we've already gone through the threshold and the attack time, and we know when it's going to start turning the volume down by the knee. So now we need to know how much it's going to turn the volume down. The ratio, I'm just going to give some examples of how much it's going to turn the volume down for each ratio. So the first example I'm going to give is with a ratio of 4:1. 4:1 would basically reduce a signal 4 dB over the threshold by 3 dB, so that the output would be 1 dB over the threshold. So that's where we get 4 dB. It's inputting 4 dB over the threshold, and we're turning it down to 1 dB over the threshold. So, or 1 dB over the threshold. So why don't we do this for a signal 12 dB over the threshold? 12 dB would be reduced to 3 dB because, you know, with some quick math right there, 3 times 4 would be 12. So 12 is 4, 3 is 1, 12 to 1. There you go. This can get confusing, so I'm going to do one more example of it. This one is a ratio of 6:1. So we're going to start with an easy example. In a ratio of 6:1 would reduce signal 6 dB over the threshold by 5 dB, so that the output will be 1 dB. Again, 6:1. And then a signal 12 dB over the threshold would be reduced to 2 dB over the threshold, and so on. The release is as the sound source's amplitude moves below the threshold again, the compressor is deactivated. But once it's deactivated, it doesn't start to turn the volume back up to where it was yet. First, it must wait for the release time. Just the same thing as the attack time, but now for the deactivation of the compressor. So the release is going to wait a set amount and then turn the volume back up to its original setting.